Hi.
I think we are live. Hi. Hi,
We are
Stefan.
live.
How
Cool.
are you?
I'm doing good. How are you?
I am fine. Thank you. Hey, we are in 2022, the first Rust Linz Meetup in this new year.
That's true. Are we still allowed to say Happy New Year?
I think we are. It's still it's already a month into the new year, but it still feels fresh and the first meetup. So I think we are allowed to do that.
There's this custom in the parts of Austria where I'm from that you're not supposed to wish a Happy New Year if you've already eaten sauerkraut.
Oh, really?
Yeah. That's close to the in the Innviertel, close to the German-Austrian border. I mean, I think how much German can you get? Then saying not supposed to wish a Happy New Year after you've eaten sauerkraut. I still don't know where this custom comes from, but yeah.
I don't know, but I already had sauerkraut this year. In fact, multiple times.
Yeah, me too. So I just screw that custom. Do you want to say something?
Hey,
we have a guest here, so I'm if I'm interrupted, that's him. Say hi.
Awesome. That's junior Rust developers, right?
Yeah. So he's now currently occupied with Lego Technic.
I see the real interesting stuff.
Absolutely cool.
Okay, let's get started with today's Rust meetup, and I think we start as always with the community news. I will share my screen for that. Give me a sec. Okay, here is my screen. So let's talk a little bit about what is going on in the Rust community in general, in the IT community in our hometown Linz, and in general in Austria. And then we'll hand over to our awesome guest speakers today. So Rust Linz, as many of you already know, is brought to you by the Coding Club Linz. It's a volunteer-led coding club. We run multiple events, the Rust Linz Meetup, and also the Coder Dojo Linz, which I will tell you a little bit more about it in a few minutes. And now to the most important thing today. We have two awesome speakers. Stefan, do you want to tell our audience a little bit about our speakers today?
Absolutely. So I'm super happy that we have two wonderful speakers today, Luca Palmieri and Daniel Stenberg. And it's great. So with Luca, we already in chats in, I guess, November, December. I like that Luca is here because I was writing my very first Rust article a couple of months ago about error handling. And I published it to the world and asked for feedback. And some said, yeah, that's really good. It's a great article. But have you checked out Luca's article on error handling? Because this one is really, really extensive. And it was. So this article is wonderful. It has everything in there that you need to know about error handling. And that's why I'm also happy that Luca agreed to join us today to talk about error handling, about his pragmatic approach to error handling. And it's also fun because one of his co-workers, I guess, said, how is Luca supposed to talk about errors? He's so perfect, he doesn't do any errors.
So no error handling necessary for Luca.
Exactly. If the program is that perfect, why we need to handle errors? But seriously, I'm really looking forward to what he's showing us today. Yep. And then we just waited out, I don't know, last week or so, where I remembered that Daniel has opened up the doors for Rust components within curl. I guess I was hearing it in a podcast with Sean MacArthur, who is the creator of Hyper. And he said that Hyper is now a part of curl. And I hope I'm correct. Let's see if Daniel is nodding or shaking his head. Okay, he's nodding. Great. So I got this one right. And then it occurred to me, but why not ask Daniel if he can show us what he's up to and how Rust and curl work together? I know curl since basically forever, so it was one of the first tools that I used when I was writing PHP. You were able to do curl requests in PHP with a couple of methods. I had no clue what it was and what it did, but I was able to fetch some resources from somewhere, and that was, I don't know, about 20 years ago or something. And it's one of my staple tools. I use it basically every day. So I'm really happy that Daniel agreed to join, and I'm also happy to see what's coming up there.
Great. So we're looking forward to these 2 talks. The only thing that is between these talks and us now are a few community news, and let's quickly go through them so that we can dive right into the Rust topic today. First, I already posted it in the YouTube chat. If you want to join our Discord server where we can have some technical discussions, or you can ask questions during the talks and we will relay these questions to our awesome speakers, here is the URL. As I said, I already posted the URL in the YouTube chat. So if you have no possibility to write it down, just take a look in the chat, click on the link, and you will be brought to our Discord server of the Rust Linz Meetup. Next one, the next events. If you are interested in IT in general and Rust in particular, the first thing, our very own Coder Dojo. Regular visitors of the Rust Meetup Linz know that every week we have programming classes, programming workshops for free for kids, starting at 8, from 8 between 17 years. And as I said, the next workshops will be tomorrow. We have a wide range of topics for absolute beginners to semi-professional. Everything is there. If you speak German, if you are in that age and you want to learn about coding, take a look at our URL here. It's mentioned here, and we are looking forward to see you there. Everything is currently online, so you can participate independent of where you are currently located. Next one, a big shout out to our friends at Female Coders. I asked them today, and they have their next study group on the 9th of February. Here is their URL, and they are also present on Meetup. Don't worry if you don't find their Meetup online yet. They haven't published it yet. They typically publish the program of the working groups of the workshops a few days before the next date. So I asked the chairman of the Female Coders, and she told me that it will be on the 9th of February. So if you are a female and if you are a woman or a girl and you want to learn about coding or get into coding, then Female Coders in Linz is exactly the community where you want to that you want to connect with. Next one, there will be an Austrian Developer Community Day. It will be at the end of February, the 25th of February. And currently, this day has an open call for papers, and they are looking for developer-related talks. And I asked them, they are very open regarding Rust suggestions. So if you want to talk about Rust, if you maybe are part of the Austrian IT community, let's go there and suggest a bunch of Rust topics. I already did. So Stefan, I also invite you, if you want to speak any kind of Rust topic. I think Rust should have a very big part of this community day. So let's flood their CFP with Rust content. I would love to see some sessions.
Yeah, cool. I might, yeah.
Awesome. So you find the URL here. Next one, Rustfest. I think, Stefan, you can tell us a little bit about the situation there.
Yeah, so Rustfest is coming up. It's virtual. They have a couple of editions, and the CFP is still going. So they have the CFP open all time. They are picking talks as they come along. So if you have an idea and you want to propose a topic there, there's still time. They ask you to maybe have a couple of propose it a couple of weeks in advance, so you can prepare. But basically, it's open all the time, and they're still looking for speakers. So if you want to speak at Rustfest, it's a global event. It runs multiple editions. The first edition was Rust in Arts, and that already happened, and it was wonderful. And I'm pretty sure the other two are going to be just as wonderful as Rust in Arts. So yeah, that's Rustfest.
Awesome. And we have two additional announcements which are beyond Rust. These are community events organized by friends of the Coding Club Linz. The first one is the Data Saturday in Vienna, happening tomorrow. And no, that's not a mistake. It is a Friday. And I know the event is called a Data Saturday. It's an exception from the rule. But this is organized by good friends of our Coding Club. And if you're interested into data science and things like that, then you should definitely check that out. And the next one is mid of February, Experts Live community here in Linz. They are very interested in cloud-related stuff and also good friends of the Coding Club Linz. And therefore, I wanted to take it into and draw your attention on these two awesome community events. the community in Austria and Linz is really great, and it's always a pleasure to talk about the things that are going on here. Last but not least, let me quickly drag that one over here. It's our own website, Rust Linz AT. We are also always looking for speakers. So if you think, hey, that is interesting, and I think I have an idea, something that I am passionate about, that I want to talk about, on Rust Linz AT, you see our ongoing button here in Sessionize. You can use the Sessionize platform to suggest talks, and we would love to see your faces somewhere here in the program of upcoming meetups, don't we, Stefan?
I have to unmute myself. Yes, we do. Absolutely.
Yeah, and that's it. That was community news. I think we should, at one point, we should have a jingle, some kind of music here. Community of news.
You mean now that we have music in the intro? You know, that's new. So yeah, let's put the music everywhere.
Exactly. So let me get rid of my screen, because my screen is not important today, and I will bring Luca up to the stage. Hello, Luca.
Hello. Nice to meet you.
Nice to meet you.
Nice to meet you too.
We are glad to have you. I always ask our guest speakers the same question. Where are you located? Where are you broadcasting from?
So I'm calling from London today.
London. Awesome. So from London to Austria. Very good. Very good. Luca, we are really looking forward to your talk.
The same. I mean, it's a shame I'm not in Linz in person. I've never been, so that would have been a pleasure. But I'm happy to be a guest, even remotely.
Yeah, maybe we will be able to set something up in the future. We are hoping to do some in-person hybrid meetups. We'll always stream, so don't worry if you are outside of Linz, you will be able to follow. But maybe we can do some hybrid events where we can invite speakers. Maybe in summer this year, we will see. We would have a location, but we will see how the situation goes. Luca, I will bring your screen up to the stage here. I think it works well. And with that, Stefan, do we have anything more to say? I don't think so. I think
so. I'm really looking forward to this talk. So, yeah.
So, Luca, the stage is yours. We are looking forward to your talk.
Cool. Amazing. Thanks a lot. So, does it work? Yes, it does. So, good evening, everybody. It's a pleasure to be here. As the title suggests, we're going to be talking about error handling in Rust tonight. Before we get started, in case I haven't had the pleasure to meet you, a little bit of an introduction. My name is Luca Palmieri, and I work as a principal engineer at TrueLayer, a financial technology company based in London. I also happen to be the co-organizer of the Rust Linz Meetup. I look after the code dojos, and in particular, we're going to have one this Saturday, which is going to be remote as well. So if you haven't seen the announcement and you search for Rust Linz Meetup, you can find the Code Dojo. Is an amazing opportunity to come and act together with other people who are getting started with Rust or good with Rust and want to work on some projects together. Strongly recommend. And if you want to know about what I'm doing, you can find me on Twitter. That's pretty much the best place to track me. Speaking of Rust, I have been doing some open source in the Rust community. I've been doing some workshops to get people introduced to Rust, in particular video on Jira with Rust. I've done some work in the web space, so faster Docker builds, easier testing of HTTP clients, tracing integrations into ActixWeb, logging in general, all the bits and pieces that I happen to solve because they are my own problems when doing applications. The last year and a half, I spent most of my time on Zero to Production in Rust, which is an opinionated introduction to backend development that uses Rust as the main language throughout the book. It's almost complete, 10 chapters out of 11, so if you're curious, go and check it out. And the whole talk today is basically a translation of one of the chapters, the one about error handling. So if you've read the book, you might hear some rhymes. So why are we talking about error handling? It's mostly because I hear more often than I like that error handling in Rust is hard. And I think that there is truth into that sentence. There are challenges in doing error handling correctly. But I think more often than not, what that sentence actually hides is that error handling in general is hard. There are different planes which intersect, and you need to tackle at the same time. If you combine that with Rust introducing a different paradigm, so instead of using exceptions, it uses values, and you might not come from a functional language, so you might not have seen that before, then I can understand why people say error handling in Rust is hard. So the whole purpose of today will be decomplecting that statement. So look at our rendering in general, and then understand how to model errors with Rust, and understand how the different bits and pieces fit together, so we can actually do a rendering and use the tools to their fullest potential. The talk is roughly structured into 3 sections. So we're going to start with a Rust-free section. It's going to be anatomy of an error, which is around error handling in general. We're then going to look at the tools to model errors in Rust. And at the end, we're going to look into the more pragmatic stuff. So patterns, anti-patterns, libraries that you can use, and things you might want to do in your applications. Without further ado, let's get started. So let's clarify with the terminology before we get any deeper. So when we talk about errors, we're generally talking about an operation that we're performing that does not produce the desired outcome. And this usually happens at runtime. And throughout this section of the talk, we're going to use HTTP calls as the example, which works pretty well considering that Daniel is the next talk, which I didn't know at the beginning when I wrote the slide. So it's serendipity at its finest. We have a client and a server. The client is using the server API to create an article. Imagine that the server is some kind of blogging platform, an API as a service, whatever you prefer. So it's posting on the article endpoint. So there's going to be a payload, which is not represented in the slide. Best case scenario, the server comes back to the client saying, 200 okay. Like, I got your article, I saved it, I published, whatever, all good. Now, we all know that that's not necessarily what always happens, no matter how well implemented our code is or how many checks we've done. What can happen is that the server comes back with an error. And let's look at one potential error that the server may come back with, 4 to 9 too many requests, which basically means I cannot handle this right now. Now, the client and the server are talking a protocol that they both understand, which is HTTP protocol. And HTTP protocol includes status codes, which has a well-defined meaning. So the client can be programmed beforehand to actually recognize a 4 to 9 status code, because the client understands what that means. And so the client can be programmed to react to that status code and perform some kind of action or routine as a reaction. And all of this happens in an automated fashion. So the client was programmed beforehand. Nobody's there telling the client what to do at runtime. So the client can look at the 4 to 9, decide to wait, perhaps an exponential backoff, and then do some retries. And if we're lucky, those retries are going to result in a success. So what we actually get is an automated recovery. So the client got an error condition, managed to perform some actions, and actually managed to get a success. If you're a user using this client software, you don't actually realize that an error happened. You might notice a little bit of higher latency, considering there's been a bunch of retries, but from your point of view, it was a 200, just a slow one, which is good. Like, that's when software works. There's other types of failure modes which cannot be resolved as easily. So let's imagine that the server comes back with a different error this time, which is a 400 byte request. And the server is telling the client that the data they submitted in the post-article request is not quite up to scratch, like doesn't actually meet the requirements of the server. In particular, the title cannot be empty, title which was part of the body that the client submitted. Now, the client understands what a 400 means, in the same way it understood what a 4 to 9 meant. But there is no viable automated recovery strategy for the client. The client, first of all, cannot understand the message field. You can do some strict matching, but let's assume it doesn't, because it's not part of some enumeration, which is part of the contract. And secondly, there's no way the client can autonomously decide, I'm going to use this as title. They cannot do that unless they're doing some machine learning or AI, but we might get some funny results if that's the case. So generally speaking, the client cannot solve this problem. A human must enter into the picture. So what we expect is that the client is going to escalate the error to the user who's actually using the client software. So the client is going to take the response, manipulate it, and spit out an error message, which is the right level of context for the user. In this case, it's going to be a title cannot be empty. Imagine the user was probably filling an HTML form, so this might be shown on the input field that required the title. And the user can actually look at the error and react to the error. So this happens this time. It's not automated. It requires an actual user in the loop. It's going to fill in the title and resubmit, which hopefully leads to a success. Now, one last type of failure mode. This time the server goes kaboom. So the server returns to the client a 500 internal server error. And once again, the client I mean, can try to do some stuff. The client could retry, but let's assume that the retry do not succeed. So what we get in the end is, once again, user escalation. But the client cannot tell much to the user because the client actually doesn't know. Can tell to the user, yeah, something went wrong. You may try again later. That might help. But really, like, the user is in no position to troubleshoot. There's no action that the user can take immediately, which is gonna lead with certainty to resolution of the error. What actually needs to happen is that something needs to happen on the other side, on the server side. And that's because we need another type of human. We need the operator. Like, the operator is a person who understands how the server works, has the right level of permissions to actually go and troubleshoot the server, and can actually interpret the errors that are coming out of the server. So the operator can go in, it might have been paged by an automated alert, they might have been contacted because the user got in touch with support saying your software doesn't work. Somehow they got into the picture. And so they go there and they look at logs and they look at traces and metrics and whatever type of diagnostic the server has, and they spot that line that says, failed to execute SQL query. There is no available connection in the pool. The operator knows how the server works, so it knows that the server is trying to insert the article inside a database, so it understands that this is failing because there's no connection available, and then can do something about it. So it can go and change the size of the connection pool, can scale up to the database, or whatever other measure it's at their disposal. Now, in all these three scenarios we examined, the 429, the 400, the 500, we had one API error that was traveling between the server and the client. And that API error had to satisfy three different audiences. There was always a user, there was always an operator, and there was always a machine. The machine, as we said, needs a stable contract because it needs to be programmed to react to that stable contract. So if it doesn't know the contract beforehand, we cannot program it to actually react when certain situations arise. And the machine roughly has two modes of operation. So automated recovery in a general sense. So it can try to do some actions as a result of an error, which might lead to ignoring the error, retrying the error, using a different strategy to get a success. Or it can escalate. So it can fail open and get a user in and say, okay, like, now it's your problem. You gotta go and solve that. Users instead can react at runtime, and they're alive, they understand what's going on. But they don't have context about the inner workings of the system. So what that means is that they cannot go in and actually troubleshoot if the server is not working. They need an error message which is tuned to their level of context, which means it's tuned to somebody who's using the software but doesn't understand the actual implementation of the software. Last but not least, we have operators. Operators understand the inner working of the system, so they understand how the all different things fit together. But I mean, they can get to understand it given enough time. So what they need is as much context as possible. They need to get each piece of diagnostic data they can possibly get, because every single one of those is a breadcrumb they might want to follow when they're trying to debug. So one error, three audiences. That error is doing triple duty. That's why error handling is difficult, because it's fundamentally a communication problem. We need to give the right context and the right information to every single audience so that they can do their job at the fullest. And that is not easy. So in the next section, what we're going to look at is how we can use the tools that Rust gives us as a language to actually model errors. I see some people are complaining about the mic, so I'm going to try to tune the gain very quickly. Hopefully that is better. Cool. So for the next section, which is going to be, let's say, roughly 10 minutes, I'll ask you to forget about how Rust error handling works. So forget about the error trait, forget about the standard library in general. We're going to use some bits and pieces. Just think about Rust as a language. So think about enums, structs, traits, all the things that Rust gives you as a language. What we're going to try to do is model errors in Rust using the tools given us from the language. So first and foremost, to solve a problem, you need to know that a problem exists. So step number one, we need to detect if an error has happened. That's going to be the first thing we're going to do. To do that, we're going to use an enumeration. So we're going to keep using the create article example throughout the talk. So create article is going to be a function. It will certainly take a bunch of parameters, which have been left out just for simplicity. And it's going to return an enumeration. So the enumeration has two states. Okay, so that was a success. And error, that's going to be a variant. And is the mic so bad? So that's a shame. Cool. So the error variant, the OK variant is going to contain the type, which is the result in case the operation succeeds. And the error variant just going to tell us something has gone bad. So, OK. When we actually call create article, given that we've been using an enum, that means that we cannot go on and assume that everything worked. So we're actually forced to use a match statement to decide which of the two variants we're actually looking at. If we're looking at the OK variant, we can extract the article identifier, and that can be used then in whatever processing we want to do. If we're looking at the error variant, then we know that something has gone wrong. The problem is that's the only thing we know. Like, the only thing we know is that something has gone wrong, which basically means we have no details, and we cannot actually give a very useful error message. We're forced to say something is wrong, and that's pretty much where it stops. This is not amazing, so the second step is we want to improve our error reporting capabilities. What that means is that we're going to add a string inside the error variant. And that string is going to be used as the error message. So that when something goes wrong, we can at least report that error message. This unfortunately works but doesn't work, because as we said before, we have two audiences, like web users and web operators. If we're only optimizing for users, then the operators are not getting enough details. If we're only optimizing for operators, then the users are getting a lot of details that they don't understand, which is definitely a bad experience. So this, it's better than before, but makes everybody pissed, depending on who you optimize for. So third step, we want to provide different error messages to users and operators. And we're going to do that in the most obvious way possible. So we're going to add another field. So we're going to have a user report field, which is a string, and we're going to have an operator report field, which is also string. And so when something goes wrong, we can log the operator report so that that gets to the operator. We're using the tracing crate here as an example. And we can print the user report, assuming that that goes to the user. Probably could be an HTTP response, could be some error shown on the screen, you name it, doesn't matter. Unfortunately, one this is okay for error reporting, doesn't quite work for control flow. If we want to do different actions like retries, as we discussed before, we need to go and do string matching. Like, we need to go and say, does the error report contain this sentence? Which is not great, because the operator report might change. It's not part of the API contract. If it changes, we're not going to know this, because the project is going to keep compiling, and then our code is now actually going to be invoked. So all in all, not a great experience. What we want is we want a stable contract, which enables us to do proper control flow, robust, that's going to be there even if things change, and we're going to notice. And the way you do that is you add another generic parameter. So we're going to have an error type parameter. It's going to be an additional field inside the error variant. That error can be any type, but we're going to use an enumeration because we have a finite number of errors. So once again, finite number of states, enums are what kills the game. So we're going to use a create article error. That's 3 variants. And this allows us, instead of doing string matching, as we were doing just a few moments ago, to actually go and match the specific variant. This has a variety of advantages. If that variant disappears, the code is going to break. So we're going to know that that is no longer a failure mode possible. So we can remove a bunch of that code. If new variants are introduced and we're actually using a match statement, we're going to get a compilation error because our match is no longer exhaustive. So we're going to have to go and think, how should I handle the new error that has just popped up? So all in all, this is good enough for us to do control flow. So to decide if this happens, I'm going to do this. But as you might imagine, there's a little bit of duplication here because we have a user report, an operator report, and an error type. And the error type probably contains overlapping information with what's contained inside the user report and the operator report. Furthermore, the user report and the operator report are generated in any case, even if they're not used. So even if we retry, for example, and that actually leads to us succeeding, we still generate a user report that was never used. So there's a bunch of string allocations and general inefficiency that we don't like. So what we can do is we can try to make that lazy. Now, we could do this by adding 2 methods, a user report method and an operator report method that return a string. But the standard library, now I'm going to bring it back into the picture, has 2 methods that we already know. There's 2 traits that we already know. One is called debug and the other one is called display. So debug is usually used and suggested for use when you want to get some developer representation of a type, down into the nitty-gritty. Display instead is suggested when you want some nicely formatted representation of a type. And so we can hijack these 2 traits and say, we're going to use debug for the operator report, and we're going to use display for the user report. And so it's just enough for the error type to implement these two things. And so then if we need, we can generate the reports we need. And these are on demand, so there's no waste. They're only generated when they need it. Sixth step. Code in general is more complicated than just an entry point that calls a function and then kind of fails or succeeds. It's usually a function that calls a function that calls 3 other functions, then in turn call 3 other 5 functions. So it's a layered cake. It's more like a birthday cake. And so what happens in our case, for example, is that create article is not going to implement the HTTP protocol from scratch. It's going to invoke some other function, probably from a library, that is going to send an HTTP request. And that can fail and speaks at a different level of abstraction. So it speaks about HTTP responses and HTTP errors. Now, our create article error has 3 variants, right? So what is actually happening in generic error? We can imagine, or we can infer, that generic error is actually the mapping of something that has happened and has gone wrong in the HTTP layer. But generic error itself doesn't contain any information about the source. What this means is that we actually go and generate the user report or the error or the operator report. This is going to be very poor because it actually doesn't include the details that would be key to troubleshoot, especially for the operator. So what we need to do is we need to store the source. So each of our error variants, if it's resulting from an underlying error, should contain the source. Now, that source is useful, but is also a problem API-wise, because that HTTP error is a concrete type. So it might be, for example, I don't know, the error type returned by request, or returned by serve, or returned by UREC, or whatever other HTTP client you might be using in Rust. And you don't want to change or break your API when you change the implementation of create article. So you want to be able to swap, for example, HTTP client implementation without having to bump up your library major version. So one thing we can use is a common technique in Rust called type erasure. So we still want to store the source, but we don't want to expose the type. And one way to do that is to use trait objects, which is basically to say, I have a pointer to a type. I don't know what type it is. I only know that that type implements the display trait and the debug trait. And this is allocated on the heap. We're using a box. So there's a little bit of a runtime cost in terms of allocation and in terms of dynamic dispatch. Now, this doesn't quite compile because trait objects are restricted. So you cannot have trait objects for multiple traits, which are not auto traits. Auto traits being sent, sync, sized, and a few other things. So the usual pattern is that you define a new trait, which requires the other 2 traits as prerequisites, and then you use that in your trait object. So that's why we're going to introduce an error trait, which requires its implementers to implement the bug display. And then we're going to say that the source is a trait object for the error trait. And this works. As I said before, though, once again, it's not a function that calls a function that calls a function. This can go a lot deeper. Function that calls a function that calls a function that calls a function. So we need to be able to get the source of the source. And at this point in time, that doesn't quite work, because the only thing we know about the source, by definition of it being a trait object, is that it implements the error trait, which means it can be displayed as an operator report and as a user report, nothing else. There's no way for us to get the source. So what we need to do is we need to change the error trait. We need to add a source method in there, which we can use to get the source of that error. This returns an option because this might be the leaf error, so the very first error that was generated, in which case there is no source. Or this could be an intermediate error, in which case there is a source. For the same reason that we don't want to show the concrete type, here as well, we're using a trait object. So we're adding the actual type of the source. Now, we've come quite far, and you could actually go and use this valuable type and this error trait to go and do error handling. So it's probably a good moment to go and double check how our from scratch first principles implementation compares with the standard library. So let's start from the error trait. So our error trait is the one on the left, the standard libraries is the one on the right. As you can see, it's actually quite close. And I'm not gonna pretend that I didn't know where we were going. So that obviously looks quite close. But it's good to go and look at the specific differences. So the standard library makes the same usage of the bug and display. The standard library has a source method as well. The difference being that the source method makes an additional request on the trait object that it's returning. So it requires it to be valid for a static lifetime. And this is a technical reason which is useful to be able to downcast, so to get a concrete type back from the trait object. As you can see, originally the standard library had a different method named cause, which had exactly the same signature of our source method. So they got time to learn and to iterate. We just did something in 20 minutes, so that's pretty fair. You can see also that the standard library has a deprecated description method, which originally filled the same purpose of the display implementation. So it was meant for a user-facing report or a nicely formatted error representation. When we look at the foldable, so at our actual concrete enum, the one that replaces result from the standard library, is extremely similar. The main difference is that our type requires the error generic parameter to implement the error trait. The standard library doesn't. There's two reasons for that. The first one is the standard library tries to be more conservative, so it tries to apply the trait bounds where they're needed. So you might find, for example, that calling expect on a result requires the error to actually implement debug, because otherwise there's no way to represent them. The second reason is that there are specific types that are actually very useful as error type, which do not implement the error trait. And this has a lot to do with coherence rules. Like, for example, boxed-in error does not implement the error trait. Specialization might unblock that if my understanding is correct, but generally speaking, there's a rationale for that. So do not be surprised by the fact that result does not require the error trait to be implemented for the error generic parameter. Now, that was quite a long diversion. So we kind of built our way into our rendering from scratch. So general understanding of our rendering, general understanding of the Rust language, kind of married the two together. We're now going to have a look at what that means in practice. So when you actually go and try to do a rendering in your own applications. Source of water required. Speaking a lot. So we covered this point before, but let's drive it home again. You should be using an enumeration as your error type every time you expect the caller to react differently to the possible failure modes, because that enables them to use a match statement, which is an extremely natural way and very idiomatic way of actually expressing a state machine in Rust. There is a caveat with enumerations around API evolution. So every time you introduce a new variant into your enum, this is going to be a breaking change, or every time you remove a variant from your enum. This might or might not be a concern, depends on how sensitive you are to breaking changes. Generally speaking, I think it's good for the compiler to break when a new variant is introduced, because that signals to you as a user that you actually need to go and review your error rendering logic. An alternative option is to mark the enum as non-exhaustive, which means that the caller is forced to add a catch-all arm in the match statement, but that has some downsides from the point of view of the user, so evaluate based on your constraints. If you are implementing an error, which perhaps an underlying error, always return a source if you can. So always go there and properly implement the error trait, including the source method. I'm stressing this because the error trait implements source by default by returning none, which is good because if you're doing a leaf error, it's just a convenience. But that also means that if you're implementing error trait manually, you might forget that it's required. In order to return something as a source, it needs to implement the error trait. So follow up to that, make sure to always implement the error trait for your errors, which basically means deriving the bug, as you see in the code snippet, and implementing the display trait, which is just the user report for your error. And then you should be good to go and report that as a source. If you are a little bit put off by the amount of boilerplate, so you need to go there and write a display representation and write an implementation of the error trait, you can use the this error trait to make that a little bit more succinct. It provides a procedural macro that you see on the left, which has its own syntax for the display representation, which goes in line, and has very convenient attributes to mark something as source. And that just generates all the code you see on the right, plus the one that is elided using comments. This error does not appear into your API, so it's purely a convenience for the developer. It has no impact whatsoever on the crate consumer, but it comes at a cost. So it's a procedural macro. It's going to bring in a bunch of dependencies, and that might increase your compile time. Consider that if you're writing a complex application, especially if you're working with web frameworks and similar things, probably you already have the dependencies in your dependency tree, so it might not actually introduce them much of a cost. So evaluate the trade-offs. Then let's code some anti-patterns out. First code smell. You have defined an enum for your errors, so it's an error type, and then every time the caller is invoking your methods and they're actually doing error handling, they group a bunch of variants together. So in this example, status 500, 502, 503, and 504, they're always bundled together and they always invoke the same code in terms of error handling. That probably means that your error enum is overly detailed. Like callers don't actually need that level of discrimination, and you would be providing a better API if it was a little bit less granular. They usually might give you a sense that perhaps is at the wrong level of abstraction. So you have different planes of abstraction playing together. So try to examine the code that is using your code and understand if that is the case. This is, of course, easier said than done. So if you're running an application and you have an internal library that you're using, then you can be very, very, very tailored to the needs of the application. If you're running a general purpose library, this can be more complicated. But generally speaking, you need to be making assumptions about your callers. Even the standard library, which is by definition meant for general purpose usage, when it tries to create a vector, for example, if there is not enough memory, if the allocation fails, it's going to panic. And that is a very good default for 99.9% of the applications. It's not a great default if you have the Linux kernel, in which case you should use a different API. But that's not necessarily a good reason to inflict an API which is well suited to the Linux kernel to people who are writing something completely different. So going to the lower possible denominator is not necessarily better. So try to understand what you're trying to do. Now the code smell, and I see this a lot in libraries, is to have a single enum error type and use that across multiple functions, which are similar, but not quite the same. So in this case, I'm using a GitHub client as an example. You have a create client function that creates an instance of the GitHub client. And this may fail in some ways, but probably it's not doing any I/O. It's just reading some configuration. And so what you see is that your caller's code only handles certain variants and then just does unreachable for the other variants. That is a sign that perhaps you need different error types that are a little bit more granular. This, once again, comes with trade-offs, because the more granular your error types are, the more constrained you might be in your implementation. But once again, it gives the callers a better understanding of the failure modes, and they can actually code properly around them. As we said during the error handling marathon we did before, always erase the type of your source error unless you have a very good reason not to. It's going to make your API more stable. And it also communicates an intent to the caller. It tells the caller, you shouldn't care about what's inside here, apart from the fact that you can print it. And that should be pretty much it. Now the tip, if you need an opaque error type, you can use boxed-in error. That's one way of doing it. You can also use the anyhow crate. The anyhow crate provides you with an error type. That error type is a little bit smaller, so it's one word instead of two, and also has a bunch of convenience methods we're going to see in a second to add context at the different layers of the stack. By default, it also has a debug representation, which provides the entire error chain, which is quite good if you're logging errors out to operators. Another myth I'm keen to dispel is that anyhow is for applications and this error is for libraries. This is not a practical framework reference. Anyhow is for any time you need an opaque error, the equivalent of an exception-based class in another language. This error is a convenience when you need to write an error enum and you don't want to go in and spell out all the different bits and pieces. But you might need error enums in applications, and you might need opaque errors in libraries. So do not mix these things up, because it actually leads to code that does not work as it should. If you're using anyhow, you can take advantage of its context methods. So you can try, when you have a workflow which spans multiple abstraction layers. So imagine you're doing a PR launch for a product. And so you have a PR launch workflow, and part of the workflow is publishing a launch article, which then invokes the create article function, which then does an HTTP call. Each of these things is a very different level of abstraction. One thing that is nice is being able to read an operator report that says, I failed to publish the PR launch article, which was caused by me failing to create an article, which was caused by 500 at a time from the server. So you can see the intent at the top, and then you go into the implementation details. That makes it very easy for an operator to understand what's going on. So if you're using anyhow, take advantage of this. And as we stressed throughout the call, every time we were talking about source, you really need to capture the whole error chain in your logs. Otherwise, it's very difficult for operators to go and troubleshoot something that says I failed to create an article or failed to open a connection. Like, what were you doing? What's the context around that? Why am I doing that? Try to give them the full context. So use that source method to its fullest. But last but not least, do not just spam errors throughout. Do not log errors continuously every time you touch an error. You want to log an error when you're rendering it. So that might be when you do, you manage to resolve it automatically, or if it's never handled, at the very top of the application. So that might be in the main function, that might be in a middleware if you're doing an API. There you have the full context, and you can print the entire operator report to the level that gives the maximum context to the operator. An operator receives too many signals, is left confused as to what it needs to look at. And that was the last tip of this talk. So I hope it was interesting for the past 30 minutes. I realized I focused mostly on recoverable errors because I think that's where most of the doubts are when it comes to rendering in Rust. Panics are a lot easier to an extent. It's when something is unrecoverable and you just want to print something out to the user. If you have any questions, I'm happy to take them.
Thank you very much, Luca. That was super interesting. Don't worry about the mic. You had a little bit of problem at the beginning, but I think you changed something. It happened every now and then, but we could all hear you loud and clear. So that was perfect.
Yeah, I tried to change the game in flight.
And I just saw that Stefan is
Hi, I'm back as well.
Yeah. Hi. So let's do a quick Q&A. People on YouTube and Discord and so on, if you have any questions, write them in the chat, either in Discord or YouTube, and we will relay them happily to Luca. Luca, I would like to start with one question that comes up pretty often in basic trainings that I do with Rust beginners. I come from a world of mainly C# and many managed languages, and people who look into Rust from that angle, one of the first things they ask me is, hey, why not exception handling? We got so used to exception handling, and now we have to go back. If you would be asked such a question from people who come from a managed language, what would be your answer?
Well, I come from a managed language, so I've been through that journey myself. I think the main problem I have with exception handling is that it's spooky interaction at a distance. So what basically happens is, if you have a complex application, you're going to have multiple layers. And so an error is going to be generated usually at the bottom. So when you're doing an HTTP call, or you're doing a database query, I mean, that's the type of stuff I deal with. And what happens is that you need to know the failure modes of the bottom layer at the top of the stack. So usually you have like some code in your middleware that says, if this specific exception type is happening, then we're going to do this. And this is all loud and clear once you're starting to write your applications. So at the very beginning, you have everything in your mind. You know exactly that this is going to raise an exception that we're going to handle up here, and everything's going to be okay. But if you're coming in hot on a code base that pre-exists, this is all implicit knowledge that you need to absorb. It can actually be very complicated. And so what I've observed in practice is that applications, as they evolve in time and they mature and the developers change on the project, then the error handling with exceptions starts to get a little bit messy. Like some exceptions should be handled actually fall through because people change the methods at the bottom and they forget that there is a handler that refers that type at the top. And so that actually is now suddenly is escaping. The other thing, which is usually complicated when it comes to exception handling, is what did I want to say? Lost it. Anyway, that's the main concept. Like it's a lot. Yeah, there it is. So when you look at a function that may fail with values, you look at the function signature, and it tells you exactly how it can fail. So I don't need to go and check the implementation. If I'm calling a Python function, for example, that may return an error, I need to go inside the function and understand what exceptions it may raise. And if that function, unfortunately, is calling other functions, then I cannot stop. Like I need to go into the other functions and understand what exception they may raise, unless that function is doing some try-catch that like recasts exception to different types. And the terrible thing is, if I update my dependencies and the implementation changes and the exception type changes, then I don't know. Like I'm not going to find out unless I have a test that exercises that code path that's going to trigger that exception, and I'm going to notice that that is not the same anymore. And unless you have checked exceptions, like Java does, which somehow mitigates this pattern, this is usually an hazard. And so makes updating dependencies a lot more complicated, which usually means that you're going to have issues when you need to do patching for vulnerabilities and security reasons. So that's my main cons for like not using exceptions. You get something else instead.
Thank you very much. Very good put, very good description. I think that will be pretty interesting and helpful for people coming from the world of managed languages. Now we have some questions from the audience, and Stefan, I think we should just display them here.
Yeah, I'm collecting.
Code and Fire.
Yeah. Exactly. Code and Fire asks, he wants to know your views, Luca, on scenarios in which it is okay to panic or use unwrap.
Okay. So unwrap is a perfectly fine solution. Usually, if you can determine by the flow of the code that a certain failure scenario can never happen. Like sometimes, like it's nice to know that something returns an option and you don't if flat, and so you know that that type is going to be something the compiler is happy. But sometimes looking at the code, you can figure out things that the compiler cannot figure out, in which case, if you comment on what you're doing, it's perfectly fine to wrap, because you know it's always going to be okay. It's like the easy version of unsafe. It's like, I know what I'm doing, I'm going to unwrap this because this is going to work. Now, this doesn't mean that you shouldn't be using unwrap in the cases where you may panic, which leads us to the first point, which is, where is it fine to panic? It depends on the application. Generally speaking, I would say you should never panic as a result of user input. Then it depends very much on the type of application we're talking about. If we're talking, for example, of a CLI, which is like launched by the user and then like completes as a result of that command, error handling concerns are different from a long-running process, for example, a multi-tenant long-running process, like a server. So if you're in a server, you don't want to enable your users to trigger panics inside your server based on the input that they're sending, because that can be leveraged because of denial of service. Also, HTTP servers in Rust do not handle panic particularly gracefully, so they're going to drop HTTP connections. So the handlers are going to be isolated, but the result on the client side is not going to be a nice 500. It's going to be connection dropped, which, depending on what client they're using, might not be as nice as you might expect. So generally speaking, in these cases, it's a better default to not panic and just always bubble up until you get an exception, like an error handler at the top that just converts that into an opaque error. If you're doing a one-off, like a CLI or some command that the user is fully in control of, then you can panic. That's easier to implement. But then you also need to reason about that panic is going to, unless you have a panic handler, like a panic hook, which is going to format the error in a certain way, they might just throw a blurb at the user saying, everything exploded, here's a bunch of like stack frames, and go figure it out. Which, you know, it's not necessarily the best thing possible. So one pattern that you can have is you can have a panic hook and then have some kind of way to set the level where it's going to panic with a nice message if it's user facing. And then you can say, well, you know, you set error level to the max, and then actually it's going to give you the full backtrace, which they could go, for example, and post on a GitHub issue if that was an open source tool. So depends. I think the frame of mind is always, we want to give the users enough information for them to realize something has gone wrong, but not much more than that. And so panic are a little bit more brittle than recoverable errors, but they can still be viable if you put the right things in place.
Thank you. Thank you very much. I think we have time for a few more questions, Stefan. Do you agree?
Absolutely. I guess we continue with Lucas. Lucas asks or thinks there is a one error message in one line convention in the industry, and what might be the issues and what might break if you violate this convention. I don't know. Do you know about this convention?
I don't. I think I routinely break it. So, I mean, there's a point in there which is valid, which is you want error messages, especially the ones which are user-facing, to be concise, because if they're overly long, they're not going to be read. So that's, once again, a motivation to keep that succinct to the right level of context. But for the operators in particular, I don't think that's strictly necessary. So I prefer to have details, structured, which I can navigate in a way which is easier for me to scan, but much better to have it too long and perhaps having to skim some context, that I've omitted some details, and then I have no way to figure out what happens. Especially if the failure is difficult to reproduce, you might not get a second chance to say, oh, I'm going to trigger that again and see what happens. Which happens a lot with threading. Not in Rust, in my experience, thank God, but in other languages, it was quite common.
Thank you very much. Awesome. Stefan?
Yeah.
Simic G. That would be another question that we could maybe bring up. The question is, how do you deal with Aero types granularization? If you have an application made up of multiple layers, do you define Aero types on each layer? And do you map them at all?
So generally speaking, yes. But I guess the thing is here is what is a layer, right? Because otherwise you're gonna have 7 function calls and you're gonna have 7 error types, and that gets very verbose and very high maintenance very quickly. So if we're looking, for example, at an API or some kind of application, I usually identify 3 layers as a base, where you have some kind of entry point that's going to have the context of the entry point and the protocol with the thing we're interfacing. Might be a CLI parsing arguments, might be a server parsing the HTTP requests, and that is one context. Then you have some kind of domain context, and that's going to speak the language of the thing you're doing, whatever that is. Might be banking, might be, I don't know, whiteboarding, app, whatever you're writing. And then you're going to have a bunch of adapters, which are, once again, the same as the entry point, but towards other systems. So they might be talking to the file system, they might be talking to an API, might be talking to the database. And each of these is a layer. And usually, yes, I define different error types at each of the levels, and they get mapped. So that allows me to reduce the level of detail at each layer, which makes the code in the layers above easier to read, usually. Because okay, I'm not trying to understand what it's a 429 here. I just want to know that my call to create article has failed in a retriable fashion. That's the level of information I need. I don't need to know anything more. And so the rest can stay in the source. Because if I need to look at that, I can print it out. So it's fine. So that's why I recommend macros like this error, because I realize that writing a lot of that code is tiresome. So if you can make it a little bit more succinct, then you're less likely to kind of to postpone that task because it's less painful. So you want to make the right thing easy to do, because then you're going to do the right thing more often, generally speaking.
Cool.
We had a question from Fred M. Regarding errors in multi-threaded code. It's a little bit too long. I tried to rephrase it, but still doesn't fit on the screen, but I will read you the rest, believe me. The question is, what are your thoughts or best practices when returning error in multi-threaded code? What is a good way to return an error from a thread? Fred M thinks that having a channel for that just to return an error seems to be a little bit of an overkill for him. So generally, what are your thoughts about error handling in multi-threaded code?
So I preface this by saying that I don't write a lot of multi-threaded code, so my opinions might be wrong or unprecise. But in the few multi-threaded code that I actually wrote, usually, yeah, that's the pattern. So you have a channel which is going to send things back to some kind of coordinator. If you're, for example, you're fanning out to do a bunch of tasks which are embarrassingly parallelizable, that's one pattern. The thing that I usually struggle with, and this is in general multi-threaded or multiple tasks in our same context running concurrently, is that there is not a great story for Rust when it comes to represent errors which have multiple sources. Like there is the implicit assumption in the way the error trait works is that the source is like a chain. So you have a source which is caused by another error, which is caused by another error. There's not the concept of a tree. Like this error actually was generated by these 3 different errors, which can happen if you're doing like, I don't know, firing up 20 concurrent tasks, 3 of them fail, the other 7 succeed, then which of the 3 errors do I pick as the source? So that is an actual problem that I find myself dealing with from time to time when I do some batching of different tasks. And I actually don't have an amazing pattern to recommend. So I think that's an open question if somebody knows how to handle that very well.
Very good, very good. Thank you. Thank you very much for being open for some Q&A here. Thank you for being our guest. Luca, I think maybe there will be some additional questions if you like, and if you still have the time, we invite you to hang around in our Discord server for a few more minutes, and then people can, on the first hand, congratulate you for this great talk, and on the other hand, ask maybe some questions. And for everybody in the audience, let me quickly show you that one. This is our URL. It's already in the chat of our YouTube stream. So if you don't want to type the URL in, you can copy it from there. And you all, including you, of course, Luca, you are all very welcomed on our Discord server.
So I'll definitely stick around to hear Daniel. So if you have any questions, I'll be around.
Very good, very good. So thank you very much, Luca. Thank you for being here. Thank you for being our guest. You're always welcome whenever you want to talk about a subject that you're passionate about. Just shoot us an email and we will be more than happy to have you again at our Rust Meetup in the future.
Thank you for having me. Absolutely. It's been a pleasure.
Thank you.
Alrighty. So I guess we go to our second speaker for today. I see Daniel is here. Yes. So I say let's invite Daniel to the virtual stage. Hi.
Hi.
Hey.
Hello.
Hello.
Hi,
And it's Daniel, because my heart skipped a beat when yesterday Nick Cameron wrote the message that he's really looking forward to David's talk. And I wasn't aware of the reference that somebody wrote you an email saying, hi, David. So I checked everywhere, in every meetup description, in every image that I created, in every email that I sent out, that I hope that I didn't write your name wrong.
No, that was a reference to another completely different side story.
Yeah.
So yeah.
Well, that was fun. Alrighty. So Daniel, where are you calling in from today?
This is south of Stockholm. Well, I'm in a Stockholm suburb in Sweden.
Cool, great. It's fantastic how international our meetup is getting. That's always very exciting. Cool. So I'd say, Rainer, what do you say? Shall we start with?
I think we definitely should. Daniel, yeah. We are really looking forward to your talk. We'll give you the stage. Do you want to share your screen, or is it currently just your picture, just as you like it?
I'm going to share my screen like this.
Good.
Cool. Yeah, we can see it.
Very good. I will put it on the screen now. Yeah. And I think that works pretty well.
Yeah, so I'm really looking forward to this presentation. This is some stuff that I wanted to dig into for a long, long time. So I guess everybody here and everybody on YouTube is excited to see what's coming up.
Excellent. So
Daniel, the stage is yours.
Thank you. Let's dive in. I have a lot to say, so I won't bore you to death, I hope. So yes, I'm Daniel. I've started a curl project. Actually, we are turning 24 years old soon. And I started working with HTTP and client-side HTTP actually already before that. So I've done my share of HTTP and stuff like that. Nowadays, I work for Wolf SSL and I do curl support. I work on curl full-time. So today I am going to try to address this and I'm going to talk about curl and Rust. And of course, curl is C. It has a stable API and ABI, a little bit about that, something about backends and the architecture of curl and how we and I did an HTTP backend and how there are other backends, and in particular then Rust in related to that. And some of the challenges that we've had and we still have, and a little bit about where we are and something maybe about where we're going. And all of that in, I don't know how long. If I'm getting too long, we can just hurry it up. So anyway, since it's really hard to take questions during this presentation, I hope you either just throw out the questions in the chats and we get them to them afterwards. I'm not going to read the chat while I'm doing this presentation, so I'm not going to interact. So if in case I'm terribly out of line, I hope someone will interrupt me or throw a question at me. So anyway, curl then, the command line tool and the library is written in C, and it has been in C since, well, almost since this picture was made. And back in the day when we started, I started, well, the first project that actually curl comes from started in late 1996. And at that time, there really was no other alternative, and especially not for doing very portable stuff and then for doing portable libraries. And actually, I would say that it was the only sane choice for a library language for a very long time. And it's also that way that C has kept and made curl extremely portable. We're counting 86 different operating systems that curl has run on, and I think it's 22 different CPU architectures. So it's literally running everywhere thanks to it being in C. And while we're now talking about doing things or components, parts, backends in Rust, the C code will remain a build option for all the different things there. And I'm going to show you how it works. So primarily here, then we're talking about, and when I talk about curl, I didn't really get into it here, but curl, you know, many people see curl as a command line tool that you can type curl and URL and it'll get the URL for you and throw out all the garbage in your terminal, but or upload it, and it handles 26 different URL scheme protocols. But primarily curl is the library libcurl, right? And for libcurl, it is very important to do stuff in a stable way. We want to be this stable bridge that remains like this even when we go forward. So libcurl provides an API that is compatible and forward. I mean, a stable API that we don't break. We don't break the API ever. We haven't changed it for over 15 years at least, and that means that you can bring your code, actually the same libcurl using code, to a lot of different platforms, and it just works there. And if you've written your code and you bring it on, even when you upgrade libcurl, it will still remain working exactly like it did before, because we don't break the API, we don't change the behavior. If you built it with the same stuff, it'll work the same way. So basically the API and the ABI, that's the front, I call it armored here. That's the front that we don't tamper with, right? We provide that API and ABI, but behind that, we can do whatever we want. And of course, all of this has sort of the stability, the availability, and the age of curl and libcurl has made it into somewhere around 10 billion installations worldwide today. Maybe more. It's really hard to estimate accurately. But of course, we have also had our share of vulnerabilities in the project and in libcurl, and estimations, or rather calculations done by me, says that roughly 50% of the past vulnerabilities have been due to what I call C mistakes. Those are, you know, the obvious ones. That is, they are, you know, buffer overflows or things like null pointer mistakes, stuff that are clearly things that are related to the C language. So there's an opportunity here to work on, or at least those could be fixed by using another language, right? So memory safe languages could help definitely with those 50%, possibly with others too. And of course, there are other mitigations to do besides considering memory safe languages. We can do other things to reduce the risk going forward. And of course, I think my prediction of the future is, of course, that we are going to do even more. We're going to have more internet connected devices, and more curl in those internet connected devices. So I think we're only going to grow in terms of usage, and, you know, the risk vulnerabilities might impose on us on the future. Okay, that's a little bit. So in curl and libcurl, we have this concept we call backends. And backend is a term we use. It's basically a selectable alternative implementation when we select those backends at build time. So you build curl with a bunch of selectable alternatives. And backends that then you can then select them, or you can deselect them, because you can select maybe I don't want this particular support at all, so I don't have to have any, let's say, SSH support. Then I don't pick any SSH backend. And some of the backends are platform dependent, so we can use platform specific libraries. For example, if you run on a particular operating system, we might use that operating system's TLS support. For example, we can build with S-channel on Windows, so to use which is the crypto SSL library that Windows provides. That's only available on Windows. So on other platforms, we can select that. And a lot of those backends then use third-party libraries that are libraries that provide things that we don't author, right? So we can actually today support a lot of different third-party libraries. So when you build curl, you select from a plethora of different available components, and everything of that creates one libcurl that you then use and ship. So all of these can then differ in features, licensing, and very much in maturity. Some of them are very old, some of them are very new. And of course, then these different backends, or actually the third-party libraries behind them, they can be done in any language. It doesn't matter to libcurl really, or it doesn't have to matter at least. And because we have these layers and we have the internal APIs that they're not exposed externally, as long as we provide a stable API and ABI, we have the liberty and freedom to change the internals, right? So we can swap out stuff internally, replace it with something else, as long as we maintain the API and ABI. And that is what we're trying to do. So basically, the opportunity, or what we're providing here is this. If you look at this third, I call it the third-party world map. It says February, so I'm a little ahead of my time. But all the green boxes here are different third-party libraries that libcurl can get built to use. They are 35 different ones. And they mostly can select them on and off. You can't have all of them because some of them are mutually exclusive, but there's a lot of them to select. And we have then, as you saw, then different boxes. So we have many different flavors of backends. Basically, you can select different backends for IDN, that's international domain names. You can select different ways to do name resolving, different ways to do TLS, SSH, HTTP3, or content encoding for HTTP, which is pretty much compression or decompression. And of course, HTTP, and HTTP being the latest one. And I'm going to get into most about HTTP because that's sort of what I did most work on recently. So basically, it's a pick and match thing. So when you build curl, there's a lot of different components that you can select from, and all of those together provide that API and ABI. All right. I wanted to then, so since we're talking about Rust in curl here, I just wanted to emphasize that we have Rust components available for these 3 different backends, for TLS, for HTTP3 and Quick, and HTTP. And HTTP then being HTTP1 and HTTP2 actually. But let me show you how it works. So this is actually work sponsored by ISRG and their Proxima project, which is a project that ISRG is running to provide more memory safe alternative for different projects. So anyway, this is how the libcurl system works. So there's a library API, and there's generic stuff for doing network transfers, since libcurl can do networking using, as I said, a lot of different protocols. So there's a lot of generic stuff for doing networking that aren't necessarily related to HTTP. But so there's, you have to create and reuse connections. There's a transfer engine that basically handles data transfers up and down and all metadata and well, fiddling with protocols in different ways. And then there's specific implementations for specific protocols. So the HTTP implementation is this big green box. And this is how it used to work. Doing HTTP with libcurl before we started to talk about introducing a Rust component. But HTTP is a lot of things. HTTP is a fairly complicated protocol. I would say fairly, it's actually very complicated. There are a lot of different things involved when doing HTTP, like authentication. You have to create headers in the request to send. There's a lot of proxy specific things. If you want to do networking over a proxy, you have to parse content headers that are related to the actual content that is transferred over HTTP, and you have to parse and handle transfer related headers, because the headers are basically split and mixed between regarding the content and regarding the transfer. And then there's HTTP1, and then there's the completely different HTTP2 transmission. So there's there's probably more than this, but at least these. And if we're then, so when we brought Hyper, which is then the Rust alternative here brought Hyper into the mix. Let's support Hyper as an alternative HTTP implementation in curl. So let's do that. But of course, Hyper is very transmission focused, so Hyper doesn't actually support everything we need for HTTP. So these 4 top things, basic authentication and some of the request headers, a lot of proxy stuff, and content parsing is not what Hyper provides. But Hyper provides more focused transmission stuff for HTTP 1 and 2. So basically what I've then proceeded, pretty straightforward. All of that, all of those things in HTTP that Hyper doesn't support for us, like authentication and proxy stuff, and I made that into a generic part of libcurl HTTP code, and then split out the different things that Hyper can do. So we can, instead of using the native code to parse transfer headers and to handle the transmission, we switch to use the Hyper code instead. So basically that's the little, go that way, go that way. That's the fork in the road internally. So when you build curl, you can build with Hyper or you can build with native code, and it will go the either other way at runtime then. Easy peasy. So when you want to build curl with Hyper, you just run configure with a different option, and it'll use Hyper then instead of the native code. So then makes it it has the high level, exactly what I just said. I showed you another version of the same slide. So there's a high level HTTP and the 2 different back ends, basically. And just showed the same thing again. So when we speak we have an application, the yellow one here. When it talks to libcurl, it talks through the public API, and the public API remains the same stable one that has been in use for decades. And then we have the core curl, libcurl, and the core libcurl has an internal HTTP API internally that it uses for everything that is HTTP, and that in turn then can select code between the built-in one or the Hyper one. This particular image I'll show you because we'll come back to the extended version of this, because at the same time, that's how we did it. That's how I split out the HTTP one, and I did this mostly last year. This I'll get back to the status. It's not completed yet, but there are other Rust-based components or backends in curl then, Rustls being one. So we support a lot of different TLS backends in curl, so you can select which of the different TLS options you want to go with when you build curl. And since, I think it's pretty much a year ago now, we can build curl with Rustls as well, or as one alternative. And we do this, of course, by Rustls providing a C API by their Rustls FFI component. So basically, I just have to make sure that, and this is how we do all this support, right? So for the support for all these different Rust components are supported by the Rust components providing a C API or a C API binding to their Rust library. And then in the Rustls case, it's called Rustls FFI. And we, of course, already supported a lot of different TLS libraries. So adding support for another one like Rustls, that was actually fairly easy. And it was especially easy for me because I didn't write it. So it was Jacob of, he's one of the head guys at Rustls, right? So he wrote most of that. So it was just adding support for another TLS library into curl. As a user or as a contributor to curl, writing curl code here, we don't really have to care about that being Rustls. That being Rust in the back or somewhere along the way, because all we see when we write curl code, we see the C API, so we interface with that. So for us, it looks exactly like any other library. A third Rust written library that we support is Quiche. Maybe not as familiar to everyone. Quiche is a HTTP 3 and Quick library. And yes, we support multiple HTTP 3 and Quick libraries as well. So you can select which backend to use when you build curl. And in this case, we're actually even more sort of complicated here because they're all experimental because Quick and HTTP3 are all experimentally supported in curl. So they're never enabled by default. You have to enable them in the build by will, because it's a bit of a I don't know, uncertain state, or early days at least, I should say. So, and again here, Kish provides a C API from their end, so we interface that C API. Curl interfaces that C API, and that in turn then uses that library written in Rust. And as I said, curl already built and support different Quick libraries, so we just made sure that we could interface this particular library as well. This was actually the first Quick library curl supported. And then you have to enable it at build time, and then it just works, hopefully. There are some details about that, but I'll get around to that, because I'm going to talk to you a little bit also about status around these different things. So this makes it work like this. So here we're back to this image I wanted to show you about Libkar Backhands, because I told you about we have 7 different flavors, if you will, of backends. So all of those are hidden behind the internal API. So if you're the application in the upper yellow cloud here, that's the application using the library. And so the library provides that public API, the stable API that we don't change. The ABI is there forever. So that's rock solid, right? But all these little orange boxes here, they are providing an internal API, and we can change that API. Doesn't have to be stable. It's not. So we can play around with it as much as we want and change it and advance it and grow it when we want to. But behind those orange boxes are different, in many cases, different third-party libraries that then actually provide the real power. And those can very well be written in Rust, of course. And you see here, there are a lot of different things, but we can just look at this. So these 3 different sort of exits then. If we look at the left, that's the HTTP3 API, and we have on the top right, that's the HTTP API, and that's the TLS API. So there are different Rust alternatives for those 3, which then, of course, implies that there are no Rust alternatives for those other 4 backend options. But of course, this is all based on history and availability and what people have done and not done, of course, and maturity. A lot of these are old things that have just been around since forever. So I guess there haven't been a real option or opportunity for anyone to provide Rust alternatives for those. So that is how we are getting Rust components into this very old project that is on a lot of places. But of course, getting all this working hasn't been, well, it hasn't been very complicated, sort of from the greater point of view, but there are and have been some challenges, and maybe some of the. So I'm talking about 3 different backends here, all written in Rust. So I've split it out here and I want to talk about specific backends. Of course, one of the challenges, of course, being the first user of something like the Hype. Actually, when I contacted the Hyper guys and Sean MacArthur then in particular, I asked them, "Wow, how's your C API? How can I use your library?" And he said, "Well, we will make one for you." So I don't know if I'm still the only user of it. I really hope I'm not, but I was certainly the first one. And being the first one, of course, I mean, I won't complain because it's awesome to get the attention and get all the help you need. And they're super cool in the project. So no complaints from me, but it means that, well, I'm early and the API certainly didn't have everything that we wanted. And I had to sort of ask for things. And it was a fairly complicated story to actually figure out how it works because headers only, no C documentation. So reading the headers, trying to understand how the API is working, that was actually pretty complicated. It's still pretty complicated if you want to use this API because it's from an old, I mean, as implied with what I've said already, I'm an old C user, API user since decades, and I'm sort of accustomed and used to how to do things and how to access APIs. And I think Rust is sort of encourages a way of thinking and a way of doing things that sort of makes the API maybe not appear in a sort of how we are used to have APIs for C programs and C libraries. So it's a little bit of an unusual thing. I'm not sure if that's Rust or Hyper, but anyway, this API at least surprised me in many ways. I had to sort of learn how it actually works, and it took some serious getting used to from my point of view. So yeah, and splitting that HTTP, as I said, I talked about before, splitting up HTTP in an upper layer and a lower layer. I hadn't really had that in my mind before, so it took some thinking. And there are also still some challenges in Hyper not doing and considering HTTP the same way as libcurl native does, but we're getting there. Right, and it's it's a journey to make sure that curl is an old beast. It has its ways, and it's been doing things just because we did it that way back in the day. I can't even remember why we did some of those, why we selected to do things the way we did, but we do now, and we want to maintain that behavior. That means we need to make sure that Hyper can also support those quirky old ways, and that's sometimes a bit of a journey. I could say that when we have these number of layers of different systems in place, and in particular when we have, for me as a total rookie, and I'm sitting here at the Rust presentation, right? But I'm not a Rust guy. I don't know Rust at all. I can maybe read some of it, but most of it just flies over my head. So I'm not a Rust guy. And when it comes to memory leaks and this unusual API for the C API here in Hyper, it can sometimes be a journey to figure out why the memory is leaking and what I'm supposed to do to make sure that it doesn't leak. So yeah, but the fact that is in the end, that the fact that it is Rust in the back there is mostly seamless, and we usually don't have to care as long as sort of everything works. And I mean, that's how it's supposed to be. And then going forward then into Rustls being another separate Rust component. And of course, all of these different backends and components, you can select them. They're sort of individually selected. So you can select a build curl with all of these 3 different Rust components at once, or just 1 or 2. And that was also a problem in the beginning too, because there were some global symbols that collided. But anyway, we're still, again, here, we're early users of the Rustls FFI, which is the C front end to Rustls. And again, being an early user is difficult because, recognize a pattern here, headers only, no C docs. So figuring out exactly how this works is not exactly straightforward all the time. So yeah, I can read the Rust documentation, but mapping the Rust documentation to the C world is not always, straightforward. But in this case, this work was mostly done by others. So this was certainly easier for me because I didn't do most of this work. It was mostly done by Jacob and others. So easier. And the TLS backend situation in curl was already mature. Actually, at this time, we already supported 13 different TLS backends. So this became the 14th. So it was mostly, adding another one in an already very established way how to add TLS backends. So straightforward, could hook it into the test suite. We could get it going very quickly. But this, I didn't say that. Well, the Rustls is not yet feature complete, not the back end in curl, and I'll get back to some detail why Rustls isn't feature complete in the library either. And of course, then the third Rust component, quiche, and again, early user of Quiche. I don't know if we were the first user of the library outside of, this is done by Cloudflare, by Alessandro and Lucas there. And this familiar pattern, you know, headers only, no C code. No C documentation. So it's a little bit hard to understand how to use it sometimes. And adding in this world, we have a messy TLS situation. And this isn't really the fault of Quiche. This is the fault of Quick in general, because Quick, let's not get into that, but you cannot use just any TLS library for this. So there's a special situation for TLS when using Quick, and that of course sort of taints Quiche a little bit, or the situation with Quiche, to build with Quiche and stuff like that. And Quiche also is not or has not been feature complete. So it, like all these other three, it's a back and forth, you know, implementing, supporting curl, going back to the developers of the project, submitting features, submitting issues, and sort of back and forth to hand in hand go forward to make sure that they provide the features we need to do the things so that we can provide everything in curl. Exactly. So then using Rust in general, of course, it's a for me, it's a sort of a wake-up call. Oh, sorry, I have to do Rust update and cargo update all the time, and I have to. But I have to say that it's really a suitable language. It works really great for this, in this case, to just replace the components one by one, or provide alternatives, provide alternative components one by one in a project like curl. Even if curl has existed since forever, we can. This is a pretty smooth ride, actually, or as smooth as you can get, I guess, even if there are some bumps along the road. But the bumps, I mean, no matter what, even if these components had been written in other languages, there would have been bumps, and there haven't been any larger or really complicated things. And of course, the parts of it is because I'm leading the curl project, and I'm a total Rust rookie, so I don't know a lot of, which is sort of sometimes bad for me, because when I run into a problem with one of these libraries, so I load up the source code, the Rust source code, and I try to figure out what's wrong here. And yeah, it's a bit of a tough road sometimes for me. Anyway, we're getting forward in this sort of in this area, and I just wanted then to get into some of the status right now, because we've been doing this for a while, and sometimes it goes fast, sometimes it goes slow when it comes to progress. Sometimes it goes slow because we're not enough developers doing things like this in the project. But anyway, so the status for Hyper right now is that it's labeled experimental and opt-in. So if you enable it in the build will say, hello, this is experimental, just consider that when you go forward. And it handles HTTP 1 and HTTP 2 really nice. And if you do this, if you enable it in your build and you run curl with it as a backend, you mostly won't notice it. It'll just transparently work exactly like curl does, and libcurl does as well. For a lot of features, like even for HTTP and HTTPS proxies, and the HTTP requests are identical, so you won't spot it even if you're watching it over the wire. Well, there might be some, yeah, well, that's at least what all the tests are verifying, so we know that they are the same. And we're at right now at some, I think it's a little bit more than 98% test case success rate. I think, well, I say there's roughly 800 test cases for HTTP. I think there are a little bit more. I think right now we have 24 test cases that are disabled when Hyper is used, and all of those 24 are subject for, you know, addressing one by one. It's a bit of a work. It'll take some time, but we're slowly getting there. So Rust Linz then, it's also experimental and opt-in, but less experimental and more opt-in. But so since that's a TLS backend, and for TLS backends, people have always well, since a very long time, been able to select TLS backends at build time. So here you just have to, at will, select the Rustls to build with when you build curl. So it's an opt-in. You have to make that decision. And for Rustls, we have then, it's actually 12 test cases, which is half of the 24 in Hyper. So it's even closer to feature perfect. There are some things not, I don't remember right now, but there are some things that isn't really implemented in Rustls yet. I think it's related to some connection thing, which makes some, for example, FTP TLS doesn't work at all. Right, and then there's this feature thing in Rustls that doesn't work yet. So they can't verify IP addresses in server certification. Server certificates, I believe, I think that's still a case. So if you, for example, you want to get HTTPS://11111, yeah, it can't verify that. If I think so. I think that's still okay. And for Quiche, that's also experimental and opt-in. And as I said, for Quiche, we have this TLS case, the TLS mess or problem. So it'll take a while until we will enable HTTP 3 by default anyway in curl. And we don't have an HTTP 3 tests yet in curl either, partly because of this TLS situation. And well, Quick and HTTP 3 are still early in general, and in the ecosystem of HTTP and open source, it's still in a little bit shaky ground. So we have, I think we have more time before we sort of feel that we have to be there. So in general, then about Rust, it works really well. You can enable all these 3 components today and go with it, and you probably won't spot any problems with it. And of course, this depends entirely on the C APIs all these 3 libraries provide. So there's a lot of C adaptions, of course, to enable us to use curl this way. And unfortunately, all of these 3 are still very under-documented, which of course, it's not Rust's fault at all. It's just, that's the status. One thing in Rust, of course, is that you can still not get it to handle out-of-memory errors in a fine way. I say fine because panic is not the fine way to handle out. If you provide a library for an application, the library should never panic or abort, because that's not the decision for the library. The application that uses the library should select if it should abort or not. The library should return an error. If you can't do anything, if you're out of memory, if you're out of, I don't know, whatever resources, or you can't connect or anything, back to error handling, right? So if a library cannot proceed and act what it's supposed to do, it should return an error. It should never panic. And in Rust right now, you can still not prevent it from panicking when it runs out of memory, which I think users of libraries for some, at least in many situations, will not appreciate. And of course, you can help to make this better, because this is the state right now, the status. We always need more help in the curl project. And as you can see here, there are Rust and there are C APIs to those Rust libraries to work on. And there's adaptions in curl then to use these libraries. So there's a lot of different areas. You can just join in and help, and you will be appreciated in any of those areas, I guarantee you. So coming up next then, in curl and Rust. First, of course, short term, hopefully short term, I don't know really, to make sure all test cases succeed. So there are, well, maybe 36 test cases to fix them. I think some of them will be problematic, some of them will be easy. So in the ideal case, we will work on this, and it'll be we can get there in a month or 2 or 3, or who knows. It depends a little bit how much time and effort we can spend on it. And then verify a few of the libcurl API corner cases that we still maybe haven't really settled, but otherwise we are already there. And then, or already now, maybe we can encourage users and developers to actually use these Rust backends, to exercise those and to really try them out in the real world and see what we have missed or forgotten, because I have this experience when I say things are experimental in curl, people tend to not really use it. So yeah, they're really experimental because nobody has used them. We need to get people to use them as well, to actually run them in the real world, to prove that they actually work as good as I want them to do, or as everyone wants them to do. Possibly I will start providing some binary builds for this to sort of ease that testing and experimenting. But also it's also a tough job to provide binary builds, and we have so many different platforms that we support, and hopefully someone else than me will help out and provide binary builds. Who knows? Maybe Docker images. So I get this question then for someone: will someone enable these backends by default? For example, there could be Linux distributions, operating systems that then select or decide to use these Rust backends by default instead of the other backends, and when they build and ship curl for their operating systems or platforms or whatever. And I don't have any real insight into how the thinking is going there, or if anyone is actually thinking or planning about that yet. But I think once we have come to that level of everything being, not experimental anymore, all the test cases are going through and everything is green, then I think at least it becomes a serious alternative and option for a lot of these distributions, for example, if they want to. I provide all the options. They have to make the decisions. And going forward, there can be more Rust components. I've talked to ISRG about that as well, and made some proposals. So maybe we'll see what happens down the road. But of course, this is open for everyone or anyone. If I showed you that sort of how we do different backends in curl, and a lot of those can be done in Rust instead, and the effect of that then being that the final binary that actually runs a lot of networking stuff would be more Rust, and then more memory safe, less C code based stuff in executing, which ideally, hopefully, probably makes things a little bit better and maybe a little less vulnerable going forward. So yeah, more backend flavors. That mean we could also introduce new things, right? We could do backends for another protocol or another feature in curl that we don't have backends for today, but we can introduce backends. Like we didn't have an HTTP backend a year ago. We created the HTTP backend infrastructure, and now we have it. We can do others like that as well. So there's really nothing in the way. We just march on, and we've been doing this for a while. We can continue doing this for as long as we want. We just march on. We keep the API, and we just get more curl going forward, with your help, of course, with everyone's help. This is fun. And I think that's about what I wanted to say today. I hope you haven't all fallen asleep. And I'm ready for some questions for those who haven't fallen asleep.
Oh, we definitely haven't. Absolutely not. Stefan is already here. Yeah.
Not even my kids have fallen asleep, so they are also still awake, bugging me. So no, that was fun. That was a very interesting talk.
Absolutely, you gave me goosebumps, to be honest, because when I hear, hey, we didn't break the API for, what did you say, 15 years or something like this?
Yeah,
I know myself. My everyday work sometimes consists of web development, and I have to update my packages today, and I did it yesterday, and I did it the day before, because every package every day changes. So your project is very different, and it was super interesting to hear about that. And we already got quite a few questions, Stefan, didn't we?
Yes.
Yeah? I already took some of the Discord questions and put them in YouTube, so we can quickly put them on the screen.
Where shall we start?
Should we start with Julius? He was the first
right from the top.
Ask a question.
Cool.
I think you elaborated a little bit on that, Daniel. Julius was asking, how hard is it to integrate the Rust tool chain? Any major hurdles?
No, from my point of view, or as sort of working with curl development, it's really easy. I don't have any problems. I think the bigger challenges are for those who actually are going to deploy or build curl for Linux distributions or stuff like that. They have the challenge. I don't have that challenge.
Okay.
So I really can't speak much about that. I think that is more of people who are actually using Rust and building Rust. You already know about those challenges, and that I think those challenges are exactly the same here too. So I don't think this doesn't introduce new Rust challenges, I think.
Okay, thank you very much. Stefan, should we take the one from Luca next?
Yes.
I think this one is interesting.
Luca asks, isn't Trust DNS a viable Rust backend to the Resolver API?
Yeah, but maybe this then just shows that I'm not a Rust guy. I don't know. Maybe. Yeah. Well, sure. I mean, we could do a lot of things probably with Rust like that. So, and when it comes to DNS, we do. Yeah. Well, let's not get into the details. I should say.
Okay.
Then we have one question from Rodrigo, which I really, really like. I guess we clicked it on the same time. With the C Rust integration, was it necessary to use some unsafe blocks of code in your project, or is it all safe Rust?
Well, I think there's a lot of unsafe, because on the border there between C and Rust, there's a lot of you have to make a lot of cop-outs and middle grounds, and so that we can transfer data in and out of Rust. So I'm sure, and I can't speak much for how to do that the best way, but of course, since you have to get data in and out of the Rust, so of course it's going to be unsafe at some point, right? If it's done in C, it's going to be, from Rust point of view, it's unsafe. So I'm sure that from a Rust point of view, that's more unsafe than not using safe, right? But from my point of view, it is I have to maintain stuff in C and then transport it over to Rust. So there's whatever we need to do, basically, I think we need to do to make sure to, even if that means there's going to be some unsafe keywords in the Rust code to handle it.
Okay. Thank you very much. Thank you very much. We have one question from one of our young coders at the Coder Dojo, really, from Alvin. I know Alvin, and he started Rust development a few months ago. He's at the beginning of his career, and I fully understand his question. He asks, hey, if you already have a C implementation for some things in place, and you talked about replacing these things, why? Maybe I can also add one question from my point of view. Where do you see the value of Rust? If you have something in C and you replace it with Rust, why do you do it? What is your motivation here?
I wanted to just go back to show you this. If you show my screen again. So this is the backends that we provide.
Trying to bring up the screen. Give me a sec. Okay.
Okay. I did.
You already did.
Yeah.
Okay. Good. Sorry.
So what I want to show here is what we already support in curl is numerous different backends. So for example, if you look at the right side, we have the different TLS libraries, and you can see 10 different purple boxes there. They are different TLS libraries that we support. One of them is Russell's, written in Rust. The others are written in something else. So the question then, why would we add another one? We already add one. We already had so many different ones. Adding another one is just the way we do things, because it provides options to those who build curl and ships curl and use curl. And usually people select different backends when they build curl, because the different backends they're providing different features. They are working differently on different platforms. They have different licenses, maybe a different maturity. So that's why you go with different backends in general. And in all of these cases, they are provided either written in C or written in Rust, or I think maybe C++ in some case. So the question in most cases is not why I would go with Rust or not. The question is up to the user who's going to pick which backend to use. So I usually defer that to the user. I support all of them, and the user who builds curl then pick one that is built with Rust or not. But of course, then that's just sort of avoiding the question. So why would anyone then select a backend that is written in Rust? And I'd say that goes back to what I said earlier. It is to provide a more memory safe option than the ones written in C. So primarily memory safety, or possibly sort of hopefully less vulnerable alternatives than the ones written in C. I think that's the primary reason. There could be other reasons as well, of course, as I already mentioned.
That was a pretty interesting answer. Thank you very much. Thank you. And thank you all for your questions. Stefan, I think we don't have any questions left.
Yes, but we have one more thing to do, especially for the audience. This is something that I started the last time when I ran the meetup by myself. For both Daniel and Luca, please, everyone in the chat, everybody on Discord, put out your clap emojis and put a lot of clapping emojis into the chat and give some virtual applause for Daniel and Luca for being our guests today and having those two amazing talks. And now we have to wait a little bit because there's a couple of seconds delay until you see all those clap emojis. But they are coming in already. There they are.
Here they are. Here they are.
Cool.
I don't know if you see the Discord, but we see a lot of clapping going on. So thank you very much for this really great talk, Daniel. And thank you for, we were glad to have you as our guest.
Absolutely.
Excellent.
Thank you so much. That was excellent.
Okay, Stefan, I think we are at the end of today's meetup. We took 2 hours, I think, and it was, I learned so much today.
Yeah, absolutely.
It was really interesting. I learned a lot about error handling, and it gave me a completely different view on this world of curl. I primarily know the CLI, and I know way more interesting stuff about it.
As said, I'm using it. I used it first in PHP in 2001 or 2002. Not having any clue what I was doing there, but that was my first introduction to it. So yeah, it was super interesting. By the way, folks, I don't know if we made an advertisement for that, but Luca has written a book, Zero to Prod in Rust.
Yeah,
I put in the chat. I put the link into the chat, and I'm also going to put it into Discord. During those talks, I was buying it, and it's fantastic.
Here it is.
Absolutely, please check it out. We see that a couple of folks in the chat ask where in Linz, which companies in Linz are using Rust. That's a very, very interesting question.
Yeah, I just wanted to ask you because you can tell us a little bit about that, right?
I can tell at least one company. That's the company I work for, which is Dynatrace. We have a couple of projects in Rust. Smaller ones, but we start actively using it, and it gives us a lot of benefits for the projects that we are doing. So, and I think there are a couple of more. So a lot of folks I know are at least Rust curious, and this is something.
Absolutely, absolutely. And we also had a company from Vienna. They do medical IT, and they were also telling us a few months ago about them using Rust in the area of imaging technology in the medical space. So maybe, Stefan, we can try to actively look a little bit more in future meetups for companies that already use Rust and tell us a little bit about it, right?
The company that you're referring to is Daedalus Informatics. They are Medizin Informatik, visualizations, exactly. They are based in Vienna, but I guess, so the speaker that we had is from Scharnstein, which is in Upper Austria. I guess they offer some remote work. All right.
Okay,
alrighty. So unfortunately, Hinge has more questions. I can't answer them. That would go way too much into details.
Maybe that is something about in Discord. From my point of view, save the date. This will be my last thing for today. This one, take a look. We already announced the 19th edition of the Rust Meetup. It will happen on February 24th. And we already have one speaker announced. We will hear about Tori, the UI framework Tori. We will have Daniel as a guest speaker. And we are currently speaking with some other folks. And we hope that we will have an interesting second talk there too.
Absolutely. So we're actively scouting for speakers. If you want to speak, give us a shout out either on Discord, either per email or a Twitter message. We are very active there, and we are looking forward to your ideas. It can be anything, something cool that you tried out, a demo, something that you learned. You know, we are beginner friendly, so please show us what you have learned. If you stumbled upon a cool project, everything from a 5-minute lightning talk to a full hour, everything goes. We had one speaker talking for 2+ hours as well at some point in time. So we are very flexible there.
Absolutely. And I think with that, we will call it a day. And thank you very much for being with us. Thank you very much for being part of the Rust Linz Meetup. See you in approximately a month.
All right.
Okay.
Bye-bye.
Bye. Bye.